All right, Algebra 2, today we're going to do lesson 14-1, Trig Identities. So we've got all these different trig identities that we're going to be using to do trig proofs, to simplify, all of that good stuff. So the identities are, these are your main basic trig identities up top, and you've already seen some of these before. Cosecant of theta is 1 over sine theta. Secant of theta is 1 over cosine theta. Vice versa. If I had 1 over sine, it would equal cosecant. 1 over cosine, it would equal secant. Same thing. Cosine is 1 over secant. Sine is 1 over cosecant. Tangent is sine over cosine. We saw that when we did exact values. Cotangent is cosine over sine. The next three are what we call Pythagorean identities. Sine squared plus cosine squared always equals 1. So whenever you see sine squared of whatever plus cosine squared of whatever, it always equals 1. 1 plus cotangent squared is cosecant squared. Okay? 1 plus tangent squared is secant squared theta. So all of these are trig identities that we're going to use to do trig proofs and to simplify. Okay, so let's start off with a trig proof. I want to prove that the identity 1 plus cotangent squared theta actually is cosecant squared theta. So I'm going to ignore the left-hand side. This is the side that I should be getting as the answer when I am done with my trig proof. Okay, we're going to do a two-column proof, just like we did in geometry, just like we did in Algebra 1. So I'm going to say 1 plus cotangent squared theta is my given. I always try to convert these to sines and cosines if I can. That's what I want to try to convert these to. So my cotangent is cosine over sine. So I'm going to convert this to cosine over sine. This is going to be 1 plus cosine squared theta over sine squared theta. Over here I'm going to put trig ID, cotangent theta equals cosine over sine. Does it matter if it was squared or cubed? No, it doesn't. If it was cotangent cubed, I would use cosine cubed over sine cubed. Okay, keep the powers with them. Now, whenever I'm adding fractions, okay, what has to be true when I'm adding fractions? Common denominator. So I got to multiply the 1 by sine squared over sine squared. So what I would have, if this is by sine squared over sine squared, my common denominator is going to be sine squared. My numerator is now going to be sine squared theta plus cosine squared theta. Okay, that's what my numerator is going to be. What did I do? I add fractions. Okay, so now I'm going to come up over here, try to squeeze it in. What does sine squared plus cosine squared equal? Equals 1. That's a trig ID right there. Sine squared plus cosine squared equals 1. So I can replace this with 1. 1 over sine squared theta. And then over here say it. Trig ID. Sine squared theta plus cosine squared theta equals 1. Okay? I know that's kind of messy, but we're just kind of going to go with it. Well, what does 1 over sine equal? What does 1 over sine equal? Cosecant. So now I'm done. Cosecant squared theta. Okay, cosecant squared theta. Trig ID. 1 over sine theta is cosecant theta. Cosecant theta. Done. There's a trig proof. Okay. 1 plus cotangent squared is my given. I know cotangent is cosine over sine, so I replaced it. Cosine squared over sine squared. Trig ID cotangent, cosine over sine. Add fractions, so I'd multiply this by sine squared over sine squared. So then I would have sine squared plus cosine squared in my numerator, all over my common denominator of sine squared. Okay, I added fractions. Sine squared plus cosine squared is 1. Over sine squared. So my trig ID sine squared theta plus cosine squared theta equals 1. 1 over sine is cosecant. Cosecant squared theta, trig ID, 1 over sine is cosecant theta. Done. And just make sure I know I ran out of room because I have a lot to put on here, but make sure that you write what it is next to it. Okay? So on number 5, it tells you the cosine theta, secant theta is 1. So you guys have easy trig proofs in these problems. So I'm going to write down my given. So I've got, so I would have cosine theta, secant theta equals 1. Again, try to convert these to cosines and sines. So which one am I going to convert? Not the cosine, it's already cosine. Convert the secant. Well, what does secant equal? 1 over cosine. So then I would have cosine theta, 1 over cosine. Okay, and that I would put trig ID, 1 over cosine equals secant. Well, what happens to my cosines? They cancel. 1. What did I do? I simplified. Done. Okay, those are your type of trig proofs that you guys will be doing. They're not too bad. Okay, you just have to make sure. Always try to get things into sines and cosines if you can. It just helps things along. Okay, it just makes it a little bit easier. Okay, let's simplify some of these where we don't have to do a trig proof, where we're just simplifying. Okay, you're only going to have to do, I think it's 4 trig proofs, 2, 4, 6, 8, I think. So 4 trig proofs. So this one here, we just want to simplify. Okay, so again, I'm going to look at this. Tangent, I'm just going to leave as tangent. So I'd have tangent of theta. Cotangent is 1 over tangent. Okay, and we learned that way before when we did the reciprocal identities. What cancels? What's my answer? Done. This one here, same thing. I'm going to convert this to 1 over tangent. So I'd have tangent of theta times 1 over tangent theta plus tangent theta. Well, when I distribute that tangent all the way through, I take tangent times 1 over tangent, I get 1. Plus, what's tangent times tangent? Tangent squared theta. So I come over here and I look at my trig ID. What's 1 plus tangent squared theta? Secant squared theta. So I'm replacing that. 1 plus tangent squared theta, secant squared theta. I'm done. I've simplified that to as far as it will go. Okay, simplified that to as far as it will go. So last one of simplifying. And again, you guys won't have very hard ones to simplify at all. Yours will not be that bad. Okay, this assignment isn't too bad. Nice little easy ones to simplify. So this one here, like number 33. Cosecant minus cosine cotangent. So now I don't have anything really fully in common. So now I'm going to convert everything to sines and cosines. Okay, I'm going to convert everything to sines and cosines. Cosecant is 1 over sine. Okay, so I'm going to change this to 1 over sine theta minus, I'm going to leave my cosine theta in there. Cotangent is cosine over sine. Okay, so I replace it. I'm going to multiply that. So I've got 1 over sine theta minus cosine squared theta over sine theta. One thing about this one, it has common denominators. So I'm just going to take my numerator and stick it over that common denominator. Now, one thing about these Pythagorean identities, okay, they can be manipulated. Okay, we can manipulate them. So what would happen if I subtracted my cosine squared over? I would have sine squared. Well, guess what? I just found a new trig identity. If I go 1 minus cosine squared theta, that equals sine squared theta. If I subtracted my sine squared over, 1 minus sine squared theta, guess what? That equals cosine squared theta. Okay, you can manipulate those. Subtract the tangent over. Secant squared theta minus tangent squared theta equals 1. Subtract the cotangent over. Okay, so on and so forth. Think about these being manipulated. They can be manipulated. So what did we just say 1 minus cosine squared theta was? Sine squared theta. So I'm going to replace that. Sine squared theta over sine theta. I can cancel. And I'm left with sine theta. Okay, so I had 1 minus cosine squared theta. I replaced that with sine squared theta. Over sine, I canceled it. I got sine theta. So these can be manipulated a little bit. Okay, they can be manipulated. So there's the trig identities. Okay, don't make it difficult. Work through them. I'm sure I'm going to have lots of questions. But I showed you a few examples. Okay, so work through it. If we need extra help, we can set up like a private Zoom meeting to go over this if we have to. So there's lesson 14.1, trig identities. Good luck. Have fun, because these are actually kind of fun to play around with. All right, we'll talk to you guys later.